Sir, where can we get your MCQs booklet? My MCQ booklet does not exist. It's non-existent, Murtaza. It is what it is. Because when I printed the theory booklet, everybody wanted me to, sir, please make the theory booklet, make the theory booklet. And so I pinpicked, that's the right word for it. I pinpicked every single question and, made a proper, beautiful booklet out of it. It's present right beside me. And then I outsourced it to a person, telling him that, just print 100 copies and, they'll be sold. And, they weren't sold. So I had to pay the amount to that person. I had to pay about, almost ₹500,000 to that person for the losses that he made. So I am not going to print the MCQ booklet. I am not going to do that. Sorry. Because people are going to pump you towards something. So I'm still getting to get humbled by organic chemistry. Why is it so easy? Because Fatima, you've studied from me. Your concepts are crystal clear. I know I look young. I look like I'm in my teens or something, late teens, 18, 19, something like that. Yeah, and guys, when will I become famous? I swear to God. When will that day come? I want to become famous, guys. Oh my God, this is crazy. Yeah. Stop crying. Please stop crying. Sir, I don't know what to do. No, you should know what to do. Don't cry, please. You're an A-level student. Come on. You're grown up. Like your parents tell you, when there's something that you don't want to do and you have to do it because your parents want you to do it, they'll say, hey, you're grown up now. You have to do this shit. And when there's something you want to do but your parents don't want you to do it, then your parents say, you're not that old now. Yeah, you're not of that. You're not of age right now. Better chup karke. That's the thing. Out of 115 students, for crying out loud, they aren't showing up to the class. Why aren't you all showing up to the class? There are, even out of these many students, there are a couple of students who are from outside the registered group. Where are my students? Why are you guys paying me? Why are you paying me if you're not showing up to the classes, guys? And I might show up. Yeah, you bought it? That's awesome. Chalo, let's start, yeah. Let's start. Hey everybody, oh shit, I've forgotten to use my mic, wait. What the hell? I'm like a Gen Alpha teacher. Which generation are you guys? Are you guys Gen Z or Millennials or Gen Alpha? What do you guys come under? Hi, I know, I look good with a shave. I know for a fact I do. Yeah, I looked like an old hag with that beard. I'm sorry, it's just some people, some people beards look good, on some people they don't. It is what it is. Okay, you're Gen Zs. Oh, awesome. Sir, I recommended all my juniors to join your past paper session. That's awesome, Safa. Sir, I don't know why I fumble while doing past paper topicals even when my concepts are clear. Atif, Jameel, I don't know if you've taken my classes. If you have, just watch me do the questions first and then you do it once on your own. You'll be good to go. Yeah. Okay. Hey everybody, we're live and in stereo. We are about to do Alkenes MCQs, the 2024 set. And without further ado, let's just start off with the first MCQ. Oh, that rhymed, guys. I'm a poet officially. Without further ado, let's just start off with the first MCQ. Guys, can somebody message me that on WhatsApp? Whatever I just said right now, can somebody message it to me on WhatsApp so I can use it? Without further ado, let's start with the first MCQ. Wow. सर आपने किसकी फरमाइश पे शेव किया? फरमाइशें हैं ना यार, क्या कर सकते हैं? My mom. Sir, we don't have this worksheet. It's okay, Benazir, it will be uploaded on your portal. It's just keep a pen with yourself and a register and try to solve whatever MCQ you see here. Try to solve it on your register. Try to write the option and maybe even write the reasoning with it as soon as you can, as quickly as you can. He got bullied by all of us, hence he shaved. Yes, absolutely, by all of you and by my mom. Oh nahi, choti ammi nahi, badi ammi. Hey, this is not your time. प्यार मोहब्बत धोखा है, पढ़ लिख लो मौका है, right? Please, and one more thing, Atif, please, if you've not studied from me previously, I hate people who write question marks on purpose, right? So I'm not going to hate you because you're new, obviously, but please, if you are saying B, be confident, say it's B and that's it. Give your reasoning and good to go, right? So don't put question marks at the end, because that just goes on to show me that you're not sure about your answers. You're very unsure, and you're just guessing. You're playing that guessing game, guessing game. So we don't want people playing the guessing game. Just be confident. It says ethene, which is an alkene, and it says it reacts with steam in the presence of sulfuric acid, and we all know this. This is basically a hydration reaction where alkenes go into what? Alkenes go into alcohols, and it's one type of what? It's a type of electrophilic addition reaction. The mechanism is not part of your course, but it is electrophilic addition reaction. So I'm not new, but I've studied from you, but I never knew that before. Okay, it's fine, Atif, it's okay. I love you, man. I love you. So we all know it's electrophilic addition. Is it acid-base? Bullshit. That's not acid-base. It is addition, and by the way, it's electrophilic addition reaction. Examiner, please write your options more clearly. It's not hydrolysis. Those who think it's hydrolysis by just looking at water, no. Hydrolysis specifically means the breakdown of compounds or molecules with water, right? The breakdown, it's like a cleavage breakdown, right? But here there's no breakdown. There's a hydrogen atom being added and there's an OH atom being added. There's no breakdown. The breakdown would have effectively looked something like this, where esters react with either dilute acids or dilute alkalis, and hydrolysis takes place, wherein the water basically from the dilute acid or the dilute alkali is used to break down the ester into carboxylic acids and alcohols. So that's how hydrolysis actually looks like. This is not how it looks like. We all know it's electrophilic addition reaction. It's not substitution, because in substitution reaction, one thing to note is whenever a substitution reaction takes place, there's more than one product that is formed, right? That's one idea. The other idea why it's not a substitution reaction is because, number one, there's only a single product being made, which is indicative of the fact that it's an addition reaction, and number two, in a substitution reaction, atoms must be substituted, right? You would see some other product being formed, right? So one idea is to look at it from the perspective of addition reaction, that hey, there's only a single product being formed, hence it's addition, can't be substitution. And the other idea is to look at it from this lens, which is the fact that there should be another molecule present here. There should be some atoms being substituted, but they aren't. So it's not a substitution reaction, hence D is also wrong. So B is the correct option. How easy, right? I didn't even have to explain it so much. Next question. Vitamin A contains retinol, and that's actually good for your eyesight, I believe, if I'm not wrong. Under appropriate conditions, acidified aqueous potassium manganate can be used to break the carbon-carbon double bond, and we all know that, right? Hot concentrated potassium manganate aqueous acidified, it is used to break the C double bonded to C. That's called oxidative cleavage. It's an oxidation reaction. After these bonds have been broken, further oxidation of the fragments may occur. Absolutely it does. You know that when you have a carbon in the double bond, in the carbon-carbon double bond, if you have a carbon bonded to two hydrogens and the double bond ruptures, you end up with what? Carbon dioxide and water. If you have a carbon-carbon double bond and the double bond ruptures and you have a carbon bonded to a hydrogen and an alkyl group, what ends up happening is this carbon double bonded to another carbon, which obviously the bond has been ruptured. This double bonded fella bonds with an oxygen, and the hydrogen that you have is going to be set aside right here, and you're going to end up with the O right here, and the R would look something like this. So effectively, if you have a carbon bonded to a hydrogen and an alkyl group, it ends up with a carboxylic acid, but not directly, by the way, right? What actually ends up happening is the carbonyl-carbon forms, which is carbon double bonded to the oxygen atom, and a hydrogen is right here and the alkyl group is right here, and then this fella further oxidizes into the carboxylic acid. So first what happens is, when the bond ruptures, if you have a C bonded to H and R, which is the alkyl group, the aldehyde would form, which simultaneously goes into or converts into carboxylic acid, and by further oxidation of the fragments, the examiner probably means this, right, that the aldehydes converts into carboxylic acids. And we know that aldehydes, when you are using hot conc potassium manganate, it's such a strong oxidizing agent that this fella forms for a split second only, and then it converts into carboxylic acids. And if you have a carbon and it's bonded to two alkyl groups, in the carbon double bonded to carbon and the double bond ruptures, you end up with what? You end up with a ketone, because a ketone is a carbon bonded to two alkyl groups, right? Now, under which conditions is the acidified potassium manganate aqueous used, and what do the final oxidation products include? Now remember, we already know that if you have cold dilute potassium manganate, you end up with diols. That's all. You just end up with diols, right? You don't end up with aldehydes, you don't end up with ketones, carboxylic acids, and therefore A and B are wrong. And with hot concentrated potassium manganate, you either end up with ketones right here, or you end up with carboxylic acids, or you end up with carbon dioxide and water, depending on what is bonded to the carbon in the double bond. You might also think that, hey sir, why is the aldehydes incorrect? Because see, you're using hot acidified aqueous potassium manganate, and hot acidified aqueous potassium manganate is such a strong oxidizing agent that the moment the aldehyde forms, it converts into a carboxylic acid. That's what happens, right? So an aldehyde does not exist for a very long time. It completely quickly converts into the carboxylic acid. And so D is the correct option because it makes much more sense. If you have this fella, it goes into carboxylic acid through this route. And if you have this fella, it goes into ketone. That's all. D is for dogs. The structure of limonene. Do you know what limonene is? It's basically a compound or a molecule found in lemon, and if I'm not wrong, even in oranges, you know. I was watching Mark Roy. Sir, but OH end पे है, so how a ketone is formed? There's no OH. It's carbon double bonded to oxygen. There's no OH here. This fella is a carboxylic acid. The OH fella. C double bonded to OOH. This fella is an aldehyde, CHO. Retinol. Where does it say OH hai? No. He's not even talking about retinol, right? He's just giving you a structure. And you have a C double bonded to C right here. These fellas are going to be the ones breaking. Just saying, kiddo. It's the oxidative cleavage. Yeah? Come on. So limonene is shown. What are the number of moles of carbon dioxide and water produced when a sample of limonene is completely combusted in oxygen? Okay, so what it effectively wants you to do is it wants you to write the combustion equation for this fella. So you're just going to count the number of carbons, hydrogens, and write the combustion equation because that's what he wants, right? So how many carbons are there in limonene? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 carbons, so C10. 1, 2, 3, 1, 2, 3, Rafa, magic 3. And hydrogens are how many? You have 3 hydrogens here, 3. This fella has already made 4 bonds. So I'll just start numbering it. So 3 hydrogens here. Then you have, this fella does not have any hydrogens because it has made 4 bonds. This fella has made 3 bonds, has 1 hydrogen. This fella has 2 hydrogens. This fella has 1 hydrogen. This fella has 2 hydrogen. This fella has 2 hydrogen. And this fella again has made 1, 2, 3, 4 bonds, has no hydrogen. This fella has only made 1 bond right here, so it has 3 hydrogens. It's a terminal carbon. And this fella has made 2 bonds, so it has 2 hydrogens. Can you guys count the number of hydrogens? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you have 16 hydrogens. And when it burns in oxygen, what does it give you? Excess oxygen mein? It gives you carbon dioxide and water. And now you balance this fella out. You balance it out. You have 10 carbons on the left. How many carbons do you need on the right? Obviously 10. So you need to have 10 here, and you have 16 hydrogens on the left. You only have 2 on the right. So what should you multiply 2 with to get 16? X is equal to 16 over 2. That's 8. Or what you could have done is you could have said, hey, however number carbons you have are then going to be the number of moles of carbon dioxide, and half this fella you're going to get water. And then you can balance oxygens as well. And we don't care about the oxygens, but you could balance them. 10 times 2, that's 20. 20 plus 8 is 28. So what should you multiply 2 with to get 28? That's X is equal to 28 over 2. That's 14. And I'm going to insert 14 here. So how many moles of carbon dioxide and water are produced? You end up with 10 moles of carbon dioxide and 8 moles of water, right? So 10 moles of carbon dioxide, and what the hell, examiner? What the hell is wrong with you? It's pathetic. Where are 10 moles of carbon dioxide and 8 moles of water? Now, what the examiner is trying to do is pathetic, but hey, I'm doing these MCQs for the first time with you guys, by the way. So hence, sometimes the examiner is pathetic and they say it's a fazul question, bakwas question, it's bullshit. But what he's trying to do is he's given you all know that it's 10 and 8, 10 moles of CO2 and 8 moles of H2O. But the examiner thought that, hey, this MCQ is too easy for students to just give it in the form of just balancing an equation. So what he did was he further calculated the ratio between the two. It's 10:8, and he further, simplified this into 5 and 4. If 10 and 8 were given, you divide this fella by 2, right? You know that this fella can further be simplified. 10 and 8 can be simplified by dividing it by 2. So 10 over 2, it's 5, and 8 over 2, that's 4. So if 10:8 were given to me, I'd circle that, but since it's not, it's then 5:4. Pathetic question by the Cambridge examiner. If you're listening to me, Cambridge, pathetic, 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 pathetic BS. This is not concept testing. This is a psychological game. Please do not test such pathetic and bakwas MCQs in the near future. Thank you very much. Next question. The diagram shows the section of an addition polymer. The polymer is made using two different monomers, okay, and it says what are the names of the two monomers that are needed to make this polymer. Now obviously the way you figure out the monomers in an addition polymer, what you do is you put a cut after every two carbons in this chain, right? So this is first carbon, second carbon, we put a cut, put a cut, put a cut, put a cut, put a cut after every two carbons in the chain, and between two cuts you have your monomer, right? You just fold them. What happens is you fold this part and make it into a double bond. You fold this part and make it into a double bond. That's all, right? So it's going to be C double bonded to C. You'll have Cl, CH3, Cl, and H. That will be the first monomer. So one carbon is bonded to a chlorine and a CH3. And then I'm going to make the double bond. Then you have this carbon C, carbon bonded to Cl, CH3, Cl, CH3, CC double bonded to C, and this C is bonded to H and Cl. It's bonded to H and is bonded to Cl. What's the name of this fella? Before I name it, I'm going to draw the other fella too, right? Similarly, this C, carbon, carbon double bond. And then this fella is bonded to CH3 and Cl. So I'm going to put a CH3 right here. And then I'm going to put a Cl right here, and this fella is bonded to a CH3 and a hydrogen. So I'm going to put a CH3 right here and a hydrogen. Right now, how do we name this fella? Select the longest carbon chain, 1, 2, 3, unbroken. Right, you start numbering from the side where the carbon-carbon double bond is the closest. Right, so this would be the first carbon right here. So, and I start naming it 1, 2, 3. This fella is called what? You have a chlorine on the first carbon and you have a chloro on the second carbon. So it's 1, 2. It's 1, 2, dichloro, 2 chlorines, dichloro. What's the name of the longest chain? Meth, eth, prop, propene. Prop 1-ene or propene? There's no such thing as prop 2-ene, is it? So 1, 2, dichloropropene. Do we have 1, 2, dichloropropene? Absolutely we do, right here in A and C. Therefore B and D are wrong. Then if we start numbering this fella, naming this fella, select the longest carbon chain, 1, 2, 3, 4. Please do not just select these two as the carbon chain and these two as the carbon chain. You select the longest carbon chain, right? Select the longest carbon chain, the longest carbon chain, please. This is the most common mistake that students would do. Sir, how would we know that they're asking for a ratio of 1? Again, I said that this question is pathetically designed by Cambridge. I'm solving it in front of you. I don't think there's any other option to it, right? I think 5-4 is the correct option, because see, the reality is it should be 10:8, but since the examiner has not given it to me, probably he's just further simplifying it into 5:4. That's the only thing I could figure out in front of you. As a student, as you guys are doing this, if you guys are doing this during the exam, this is the only way about that you could figure out, because in A level sometimes they just test psychology, and this again I said is a pathetic MCQ tested by the Cambridge examiner. But if you were to ask me on what basis do we know, you just have to use your brain there, because you don't see 10:8. So you have to figure out that okay, there must be something else to it, because you've done balancing correctly. So there's no other option then to further simplify it. That's all. And I think if you check the marking scheme out, I don't have any marking schemes by me, but I know that these options are correct, because concepts work, guys. Concepts work. You don't have to, trust me. You can search every single option out after I solve them, and then let me know if you think I've done anything wrong. I just like to test myself too, and it's good. So this is 1, 2, 3, and okay. One more thing to realize. See, this I can start numbering from here to here. I can start numbering 1, 2, 3, 4. I can start numbering like this, and I can also start numbering like this, 1, 2, 3, 4. How do I number? Now what you realize is, hey, there's a tie between where the functional group comes. If you start with the white numbering, you're going to end up with the double bond between the second carbon and the third carbon, right, which is obviously going to get the number 2. If you start numbering like the green numbering, you'll again end up with 2 and 3 for the double bond, right? So you're gonna call it 2, because there are 4 carbons effectively, and if you want to name the longest chain, it's going to be called but. And what ene? Again, between 2 and 3, the smallest number is picked out, which is butene. So this fella is butene regardless of whether you take the white numbering or the green numbering. Now the question is, do we take the white numbering or do we take the green numbering? Because what you realize is you also have a substituent, and alongside having the shortest or the lowest number for the functional group, you also have to give the lowest number to the substituent. Now in one case, in the green case, you have the chloro on the third carbon, and in the white case, you have the chloro on the second carbon. So if there's a tie, it doesn't matter if you take white or green for the functional group, you then have to look towards the shortest or the smallest or the lowest number for the substituent. So I'm going to take the white numbering because that's what IUPAC says. So I'm going to take 2, I'm going to take the white numbering, the chloro is on the second carbon rather than the third carbon. So I'm going to say, hey, it's 2-chloro. It's 2-chloro-butene. Do we have 2-chloro-butene? 2-chloro-butene, absolutely 2-chloro-butene. Therefore, C is wrong, A is the correct option. Done? सर एग्जामिनर को पानी का ग्लास लेकर डूब जाना चाहिए ऐसे क्वेश्चन पर? नो, द एग्जामिनर should just kill themselves. Awesome guys, I'm loving this. Now next, the diagram shows the structural formula of a hydrocarbon molecule Q. How many carbon atoms in the molecule are sp2 hybridized? Now we know sp3 hybridization is what, when you have a tetrahedral structure, and not just a tetrahedral molecular geometry. It's never about the molecular geometry. I have taught you guys hybridization in a lot of detail. It's never about the molecular geometry. It's always about the electron geometry, right? But since all the carbons are involved in bonding, we couldn't care less. You know, you can call sp3 hybridization as tetrahedral structure, which will be a carbon making bonded to 4 atoms, not making 4 bonds, rather than making 4 bonds, being bonded to 4 atoms. Like this fella is sp3 hybridized because it's bonded to 1 atom, 2 atom, 3 atom, 4 atom. It has a tetrahedral electron geometry. This is the first electron domain, the second, the third, the fourth, right? And sp2 is effectively what? It's trigonal planar when carbon is bonded to 3 atoms effectively. But again, this concept is incorrect. It's just a shortcut, right? When carbon is bonded to 3 atoms and blah blah blah. I've taught you guys the reality behind things. Teachers make you rote learn these things. I don't. And sp hybridized is linear, because I don't have time to go into the entire concept of hybridization, but this is what you need to know to solve this MCQ, by the way. So if you start looking at the carbon, this fella is bonded to 4 atoms. This is tetrahedral, so this is not sp2 hybridized, it is rather sp3 hybridized. This fella is also sp3 hybridized. It's normally the carbon-carbon double bond which is sp2 hybridized. So this fella, see, it's a trigonal planar structure. This fella is sp2 hybridized. This fella is sp2 hybridized. And then see, this fella, again, carbon being bonded to 1, 2, 3 atoms. This is also sp2 hybridized. And then you might get carried away by circling this too. You might say, hey, so there's a double bond here and double bond here, so this fella is also sp2 hybridized. No, absolutely not, because it's only if a carbon makes 1 double bond right here and the others are single. This fella has made 2 double bonds, a double bond here and a double bond here. And by the way, this is linear. This is sp hybridized, right? It has 2 electron domains. This fella is sp hybridized, not sp2. And if you look at this fella right here, this fella is sp2 hybridized. See, it's trigonal planar. 1 atom here, the other here, and the other here. 3 atoms and no lone pair. This fella, 3 atoms and no lone pair. This fella, on the other hand, is bonded to 1 atom here and the other atom here. This fella is again linear. This is the sp hybridized, and this fella is sp hybridized, and this fella is sp3 hybridized, right? Because it's bonded to 4 different atoms and no lone pair. 4 atoms and no lone pair. So how many trigonal planar sp2 hybridized fellas do you have? 1, 2, 3, 4. B is the correct option. That's all. That's how easy these MCQs are, by the way. And thank you guys. Thank you. I know it's not about me. It's about how good you guys are. I'm just a mere guide, guys. Question 6. Synaltach resins can be made by polymerization of fluoride monomers, including blah blah blah. What structure represents the repeat unit in the polymer? Is given you this fella. And remember, whenever you were to make a polymer or whenever you want to make a repeat unit, make sure that you simplify it for yourself. Whenever you have a carbon double bonded to another carbon, and obviously AS level, you only have the addition polymerization as part of your course. So what you do is, the carbon and carbon involved in the double bond, you just make all the other things go above and below it. That's all. You just make the carbon and carbon double bond, and then you just make all the other atoms in the groups above and below it. Like so, I'll show it to you. So here is carbon double bonded to the other carbon atom. And then what I do is I make these 2 hydrogens go above and below, and this fella, this hydrogen goes above or below, doesn't matter, and this CH2OH goes below. That's how it should look. And then you just break the double bond. So you say, hey, the double bond breaks, and you make the connectivity bonds like so. That's all. Just make sure that you make the carbon and carbon double bond, and just make everything go above and below it, break the double bond, and extend the two lines to show the connectivity bonds. That's all. So if I look at my options, which fella shows me the correct option? And that's B. And as you see, it's one carbon bonded to two hydrogens, the carbon bonded to two hydrogens. This carbon is bonded to a hydrogen and is bonded to CH2OH, and then you have these connectivity bonds. That's all. I don't even have to eliminate all the other options. This fella is, I don't know what this fella is. He's probably tried to show you like, a condensation polymerization, but it's nothing. I don't think what they're. These are just pathetic. Pathetic options that the examiner has given. They're not even confusing at this point. How can you have a carbon-carbon double bond left in this polymer, when there was an addition polymerization taking place? How do you have this as polymerization? How is CH2, CHOH as the polymerization? Because remember, this fella the masla is not about the number of atoms and the number of hydrogens. The masla is that in the straight chain, whenever you make the polymers in the straight chain, you must have two carbons, and if you don't do that, what will end up happening is between two carbons you have the monomer. So effectively you are telling the students that the monomer is CH2 double bonded to CH2, and that's not the monomer. The monomer is this one fella right here. So always remember, and if I put two cuts between two carbons here, see, if I put a cut here and a cut here between two carbons, this, and then I just put a double bond here, this entire fella becomes the monomer. I just add the double bond, and this equals to this. Easy. So B for Reno. Which reaction occurs when ethane, which is an alkane, and chlorine are mixed in diffused sunlight? So effectively UV light. That's called a free radical substitution reaction, right? So a free radical substitution reaction, and hydrogen is given off. Absolutely BS. It's HCl which is given off, right? So you have Cl2. What happens is a single chlorine atom goes here, and you have a hydrogen bonded with chlorine, so you get C2H5Cl, which is chloroethane plus HCl. And obviously I've just done the O-level IGCSE bit. You know the mechanism for it. I can't be bothered. In O-level IGCSE, I used to teach you a chlorine atom goes and a hydrogen atom comes here. And in A-levels now, it's called free radical substitution reaction. Initiation happens, propagation happens, termination happens. But to solve this MCQ, you don't need to, start writing all the steps in the chain reaction. So you can just use the O-level IGCSE knowledge, which is chlorine ja, hydrogen a, chlorine ja, hydrogen a, chlorine ja, hydrogen ja, say it, ja. So it's HCl which is given off, not hydrogen. Pathetic. Hydrogen, it's a free radical substitution with hydrogen chloride given off. Absolutely, it's HCl, steamy fumes. C says a free radical substitution with no gas given off. Are you blind, the examiner? A nucleophilic substitution with, it's not nucleophilic, because in a nucleophilic substitution reaction it happens in haloalkanes, SN1, SN2, remember? Where a nucleophile initiates the reaction. Maza aa raha hai? It's so fun. Awesome. I'm glad it's fun. Because see, if your concepts are clear, everything will look fun to you. If they aren't, then you're just cooked. Take the lectures. Question 8. I always say the MCQs are easier in AS level. I don't know why students think they're difficult. Why do students think MCQs are difficult? I'm doing them for the first time with you all. It's a piece of cake. I'm doing it literally. A molecule, if I can do it, you can do it. Where is my charger? Wait, guys, wait a moment. I'm going to plug in the charger right now because the charge is finishing. Guys, I want you all to do something. I want you today, after this class, what I want you to do is, I want you to go to your parents, and when they are right about to go to sleep, or when they are doing something or using their phone or watching dramas, what you just do is, please just do this for me. Just go to them, go closer to their ears, and just go like, and then see how they smack you. It'll be so fun. Send me a recording if possible. Yeah? I sometimes go to my mom and just go like, and then she beats the crap out of me. She says, "Bus now. You're an old man now. What the hell?" Just do that for me, please. Even if they're mad at you, or even if you're mad at them. Normally it's the other way around, but again, I can't say anything about this generation. Why does every teacher say, "Oh my god, this generation did it"? So you should send a video of you. I think my sister made a video of me once. I'll ask her if she has one. My mom, but she also made a video recently when I went back home, and my mom was like, I will tell all your students that you don't eat food, you don't take care of yourself, and this and that, and this and that. But she was talking to me in Pashto. I don't know if you guys understand Pashto. I don't know. But she was बेइज्जत सर मेरी बोटियां मामा जैसे सर मेरी बोटियां सेरी में खा रहे होंगे. As fun. See, chemistry can be fun if you make it fun. Just start doing these questions and just be like, just do that. I know I look young. I look like I'm like 19, 20, 21. 21. Can you do some for me? Hey, पानी. Oh नहीं बचे. #no homo. Sir, how old are you? Yeah. Good question. Very good question. Next question. Sir, I'm not trying to be homeless. I love this. Hey, you won't be homeless. Can you all answer this question? A molecule of Jaraniola, blah, 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 blah. What is found when it reacts with excess cold dilute acidified manganate ions? Effectively KMNO4, right? So potassium manganate. Aqueous. What happens if it's cold? The diol forms, and so what happens is the double bond breaks. You end up with a diol here, tuck and tuck. This fella becomes OH right here, and this becomes OH right here. And which option is that? This OH is already present, so it's OH, 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 OH. Yeah, you'd only be rupturing the bond. You'd only be rupturing the bond if it were hot. Conch acidified manganate ions. I don't even know what the hell they did here, and I don't even know what the hell they did here. What they did here, I'll tell you what they did here. In D, they're basically trying to make you think that when you're using this fella, the alcohol, the primary alcohol, goes into carboxylic acid. Well, is that not the case? That's not the case. You know what happens here? Which fella do you use? Which oxidizing agent do you use for the primary alcohol to go into carboxylic acid and for the double bonds to not break or to not go into diols? You could just use an oxidizing agent, which is like acidified aqueous potassium dichromate. You could use dichromate because dichromate is not strong enough to form diols or even to rupture the bond. So you can oxidize this fella. Mild oxidizing agents. Question 9. A section of 2 repeat units of an addition polymer is shown. Which was the monomer? Again, I'll just fold the bonds, tuck and tuck, fold it, C double bonded to C. This is CH3, Cl, CH3. This is O level IGCC, basic stuff. Just need to name this fella. How do you name it? Select the longest carbon chain. 1, 2, 3, 4. That's 4 right here. Uno, dos, tres, cuatro. Now the question is, how do I number? How do I number? Sir, single. Sir, ये वाला समझा दें. Single arrow. What single arrow? Just you could just make a cut. It's up to you. If you don't like this, just make a cut. I'm just saying fold the bonds. If you don't like the concept of folding the bond, just make a cut. Between 2 cuts, you have your monomer. And just add the double bond. Happy now? What are you saying? Homolytic fission, वगैरह. I was just saying fold the bond back. How did this polymer form? Effectively, the double bond broke. You had a connectivity bond here and the other carbon bonded with the other fella, right? So what I'm doing is I'm making the double bond again. That's the only difference. Put a cut between 2 carbons in the chain, and between 2 cuts you have the monomer. Just put the double bond here. That's all. Or you could, if you don't like this, you could just say, hey, we just fold the bond back up. That's on you. However you want to do it. The question is, how do you name them? Now there are 2 ways. Again, we have a substituent which is chloro and we have methyl. Okay, keep that in mind. Now I can start naming, and again, these MCQs, if I were the examiner, I would test you with difficult options. The examiner here has not tested you guys with difficult options, by the way. But if I were the examiner, I would perplex you here. Why? You see, you can do naming like this: 1, 2, 3, 4. But if you do the naming with the blue pen, you could say 1, 2, 3, 4. And what you realize is, hey, in both cases, you end up with what? Bute, because 4 carbons, and there's a double bond between the second and the third. So in both cases, you end up with butene. Now the question is, in one case, you end up with 2 chloro, 3 methyl butene, and the other case, you end up with 2 methyl, 3 chloro butene. Which one is correct? That's the question. Do I give the smaller number to chloro, or do I give the smaller number to methyl? Here, I've already taught you. The white fella is correct. Why is the white fella correct? Because C comes before M. So you follow the alphabetical order. So it's what? 2 chloro. Not 2-methyl, it's 2-chloro-3-methyl butene. So where is 2-chloro-3-methyl butene? Here, 2-chloro-3-methyl butene. Now if I were the examiner, see, the examiner has not given you this option. If I were the examiner, I'd also have given you guys this 3-methyl, sorry, I'd also have given you guys this 2-methyl 3-chloro butene. If I were the examiner, I would also add this to the options. And if Cambridge, you're listening, please add this to the option to actually test this concept. Because if the Cambridge examiner is not adding this to the option, then you're not actually testing students' concept, whether they know that once there's a tie between the parent chain, what do you do? So please test this concept, Cambridge. Don't give the easy options. It's not butane. And by the way, you could have solved this question. Again, I'm here to teach you how to solve questions and how to quickly solve them, and I'm here to revise your concepts with you all. I'm not here to show off how quickly I can do it. So I will take my sweet time on every single MCQ, even though you might think I'm just doing shenanigans. I don't care. I couldn't care less. But what I could have done here is, instead of using any instead of using my brain here, I could have done one quick way to solve this MCQ. What would be that quick way? If I were short on time, I'd say, hey, it can't be alkene because it's an addition polymer, so it must have a double bond, and so it should end with an ene. So A would have been incorrect. That's how quickly I had put this incorrect. It can't be pent to ene because after every 2 carbons I put a cut, and this is 1, 2, 3, 4, so can't be pent. So C is also gone. And it can be 2,4-dichloro because he's using all of this feather, and it can't be this, so I'm just left with B. That's how quickly I could have done this MCQ if I weren't, if I were short on time, and if I, did not know the concept. So it's all about the gamerino. It's all about the base, and chicken. It's all about the base. Question 10. Z is a gaseous hydrocarbon. Okay, gaseous. I'll keep that in mind. It's gas. It has a density of, what the hell? Why are you giving me density? Okay, if the examiner has given me something, he must have done it for a purpose. So I'll say density equals mass over volume. I'll just write this for my own sake. I don't know why he's given it to me. Frankly speaking, I'm doing this for the first time, so I don't know. But density equals mass over volume. And under room conditions, we know under room conditions, if you have a gas, it's going to occupy a volume of 24 dm cube or 24,000 cm cube. Right? I know this stuff for a fact. So I have the volume and I have the density. Okay. So what I can do is, I can say, okay, he's given me the density. I don't know the mass of this gaseous hydrocarbon, but I know the volume, which is going to be what? The volume of 1 mole of any gaseous hydrocarbon under room conditions is 24,000 cm cube. Why am I using cm cube? To cut this cm cube off, right? So I say, hey, density is 3.50 times 10 raised to power minus 3 equals mass over volume. And if I were to calculate the mass out of it, I'd say, hey, 3.50 into 10 raised to power minus 3 is the density times by volume, which is what? Which is 24,000 cm cube. Why am I using 24,000 cm cube? Because see, density is given in gram per cm cube. So the cm cube cuts out. And effectively, what do you end up with as the mass? I've not read the question. I'm just solving, KR, what has the examiner given me? So I'm ending up with 84 grams, which means that if I have 1 mole of Z, is going to weigh 84 grams, and effectively that's called the molar mass, which is equal to the MR. What that means is, hey, the MR of Z is what? 84. That's how beautifully I have deduced this idea. Because 1 mole of gaseous Z is going to weigh this much, and 1 mole of any substance, the mass of 1 mole of any substance is called molar mass, and molar mass is equal to the MR in terms of magnitude. Right? So 84 is also the MR of this fella, right? So that's one thing. Do I have 84 in my options? No, I don't. Okay, this question discusses something else then. Z reacts with an excess of hot concentrated acidified potassium manganate. So if you are reacting with hot concentrated oxidizing agent, what that means is the double bond is going to rupture, and using only one type of carboxylic acid is formed. Now there are two ideas here. Number one, a carboxylic acid forms. We know our 3 scenarios. If it is C bonded to 2 hydrogen atoms, carbon dioxide and H2O is bound to form. If it's C bonded to a hydrogen and an alkyl group, and then the double bond ruptures, obviously what happens? The double bond ruptures, you end up with what? An oxygen comes here, an aldehyde forms, and then obviously the aldehyde converts into a carboxylic acid. So effectively, if I have C bonded to a hydrogen and an alkyl group in the double bond, this fella is going to give me a carboxylic acid. But then again, he's saying one more thing. And I know my third case scenario, if you have a carbon bonded to two alkyl groups, then when the double bond ruptures, you just end up with the O here, the O, which is because of the oxidizing agent, and this fella is the ketone then. So he's saying that number one, carboxylic acid is going to form, which means that you must have C bonded to H and the alkyl group. That's one idea. The other idea is saying he's only one type of carboxylic acid is formed, which means that it must be a symmetrical alkene. It must be symmetrical. Only if it's symmetrical would it result in one type of carboxylic acid. I'll even show it to you right here. If I'm saying butene looks like this, I can just draw the cis version of it, couldn't care less. If you break butene in half, see, it's a symmetrical alkene, and it's butene, and I know most of you guys are not familiar with skeletal, so I'll show it to you like this. If you're not good with skeletals, it's okay. Meth, prop, and bute. See, if this double bond were to break due to the hot concentrated acidified potassium manganate, you have a C bonded to a H, and this fella is the alkyl group, and I'll even show it to you in this way. So this is a hydrogen and this is the alkyl group, and the double bond broke, and even here it's a hydrogen and this fella is my alkyl group, and the double bond broke. And so what actually happens is you end up with the O here, this hydrogen shifts a little to the right, ends up with the O. First aldehydes form, and then you end up with the carboxylic acid. So see, you ended up with one type of carboxylic acid. Why? Because it was a symmetrical alkene. You ended up with a carboxylic acid because of a carbon bonded to a hydrogen and the alkyl group, carbon bonded to a hydrogen and alkyl group. You ended up with the carboxylic acid, and it was the same type, the one type of carboxylic acid, because it was a symmetrical alkene. We have to keep this in mind. So A can potentially be my answer. A can be potentially be my answer, but it's not. A is not my answer. Do you know why? I've done some calculations above, and I know A is not my answer. I'll connect it to those calculations in a while. 2,3-dimethyl butene. Now again, I don't like to use these. I like to draw the skeletals for it, but I know a lot of you guys aren't familiar with skeletals that much, and you aren't comfortable with it, so I'll draw it for you. Butene. Again, it's CH3. Bonded to C, bonded to H, double bonded C, bonded to C, that's bute. I'll draw the hydrogens at the end, by the way. So this fella is butene, and it says 2,3-dimethyl. So on the second carbon there's a methyl, and on the third carbon there's a methyl, and even this fella is symmetrical. See, if this fella were to break, this is also symmetrical, but the problem here is the carbon in the double bonds are bonded to two alkyl groups. These are effectively two R's, and if you have two R's bonded to the carbon, you'll end up with a ketone and not a carboxylic acid. So therefore B is wrong. Sir, half of these MCQs can be just solved using common sense, which I lack. No, it's okay. Don't lack common sense, but absolutely it can be done using common sense. You're absolutely right. You think it's common sense, Fatma, because you studied from me. You studied from me. No, I'm joking. It's your own efforts, yeah. I'm joking. Then students say, sir, boasts about himself. No, I don't. Hi, Pani. That's ketone. That's not the option. So this was symmetrical, but it ended up with a ketone, not a carboxylic acid. Hex-2-ene. Can I just quickly do this? Meth, eth, pro, bute, pent, hex. And saying hex-2-ene, so the double bond is between the first and the second carbon. I couldn't care less. It's not going to be symmetrical. See, it's not symmetrical, so I'm not going to even look at it. It's asymmetrical. A big fat A. See, there's more of a chunk here than here. So if the double bond were to break, no, this fella would go into carboxylic acid, obviously, and even this fella, because it's a hydrogen and the alkyl, both would go into carboxylic acid, but they'll give you different types of carboxylic acid. Couldn't care less. C is wrong. And hex-3-ene, 2, 3, 4, 5, 6. 1, 2, 3. So between the third and the fourth carbon, you have the double bond. That's why it's called hex-3. And in C, if this fella were to break, this would give you two carboxylic acids, and they would obviously be both symmetrical, right? Because it's between the third, it's hex-3-ene, right? Hex has 6 carbon. The double bond is between the third and the fourth carbon. So 6 jo hai 3 pe divide ho jata hai, right here. And you could even draw the displayed structure for it. I couldn't care less. And you would end up with carboxylic acid. How? You see the carbon in the double bond. See, I'll even show you the dotted lines. This carbon and this carbon is bonded to an alkyl group, Okay, this carbon, the blue carbon is bonded to this alkyl group, this blue carbon is bonded to this alkyl group, and the other bond that it has made is obviously with hydrogen, which is not shown in skeletals, right? So yes, you have hydrogen and alkyl, and you will end up with carboxylic acids effectively. So D can also be my option. Now the problem is, sir, what was all the data given to you above and why did you use it for this particular day? A and D both can be my options, but it needs to have the MR of 84. And between butuene and hex3ene, butene is effectively what? C4H8. And hexene is what? C6H12. Which one has the MR of 84? It's probably hexene, because see, 6 times 12 is 72 plus 12, that's 84. D, Reno. Everybody's right. Awesome. I'm glad, guys. I am glad that you were able to solve these MCQs. I'm crazy. I know I'm crazy. You're crazy too. Do you know why? Because you're sitting in a crazy teacher's class. I'm a crazy teacher. I'm a mad hatter. Big stepper, underground medgird, bed dever. Okay. Yeah. मैं थोड़ा सा ना ओवर हूँ, मैं हूँ ओवर, सॉरी मैं हूँ थोड़ा सा ओवर, ठीक है ना. I'm a little cracked because when I was born, I'll tell you something, and please, it's just between you and I. When I was born, my mom tells me now that when I was born, I actually fell off her godi. So she was holding me in her lap and I fell off her lap, hit my head with the wall and or with the floor, and that's how I'm here today. Wow, Shine. Chup, bilkul chup. The diagram, I'm cracked, man. The diagram shows a simplified structure of coenzyme Q10. Couldn't care less what this is. Which row describes the structure of coenzyme Q10 correctly? Is it an aldehyde or a ketone? It's not an aldehyde because it would have had the CHO functional group, which is C double bonded to O and H here. So it must have had a terminal carbon which has this bit. It has no terminal carbon which has this bit. It is ketone effectively because see, you have carbonyl carbon with alkyl groups surrounding it. Carbonyl carbon with alkyl groups surrounding it. And that's what ketones are. It's carbonyl carbon with alkyl groups. So A and B are wrong. This is how easy they are. And then it says the number of pi bonds. So you have a pi bond here. The second bond is always a pi bond, right? Sigma and pi. So you have a pi bond here, a pi bond here, a pi bond here, a pi bond here. So effectively you don't have 2 pi bonds, you have 4 pi bonds, and D is the answer. What is this N doing? N is basically representing those who counted this as a pi bond. This is also a pi bond, but this comes under the category of N. So what this means is you're going to have N plus 4 pi bonds, which means these 4 will always be pi bonds, and then the number of pi bonds would depend on the number of units here. So if these are 4, you'll have 4 pi bonds. If these are 10, you'll have 10 pi bonds. If they're 50, you'll have 50 pi bonds here plus 4. So that's what this means. The molecular, sir, this isn't fair. Why didn't my mom drop me? I don't know, kiddo. I don't know. Organic had me stressing about sub, but doing these endless revisions, I finally think I'm in a safe zone. Thank you, sir. Benazir, welcome. It's all your efforts, kiddo. I always say I tend to, just make fun out of myself, but it's seriously your efforts. I'm just a mere guide. I just deliver concepts. It's on you guys, your own efforts. If you guys feel chemistry is easy, it's your own efforts. If you find it's difficult and if you've taken my classes, then it's my fault. Please contact me personally. I will talk to you and I'll take full responsibility and accountability, provided you've taken all the lectures and you've taken my practice sessions. If still you find chemistry difficult, it's my fault. But if you find chemistry easy by taking my lectures and my practice questions, it's your own efforts. That's the idea. That's how we roll. The molecule limonene is C10H16, contains a 6-member ring. So 2, 3, 4, 5, 6, like this. And says this is the only cyclic component. So if this is the only cyclic component, it says which volume of hydrogen in room condition to react completely with C double bonded to C bonds in 1 mole of limonene. Now this is a beautiful question because limonene. Now you're not expected to know the structure of limonene, although limonene structures look something like this. Tuck, 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 tuck. Can you guys tell me how many hydrogens are required? First, I'll tell you the concept, and then I'll show you how you would be able to do it in the exam. Can you guys tell me how many moles of hydrogen would be required? How many moles? See, for 1 mole of pi bonds, for 1 mole of the double bond, you have 2 double bonds, right? So you would require 2 moles of hydrogen, which is effectively what? 48 dm cube. How? Because V is equal to N times 24. If you have 2 moles of hydrogen, how many dm cubes are this? 2 times 24, that's what? 48 dm cube. Isn't this easy? So you will end up with B. Right, B, but sorry, C, not B, C, 48 dm cube, right? 48 dm cube. Now, this is because I've shown you the structure of limonene. Now, in the exam, you as a student are not required to know or rote learn the structure of limonene. How in the world will you do this question? Because see, if I were to give you the structure, you know the number of double bonds you have are going to be the number of moles of hydrogen required, and you could convert them into volume and just multiply it with 24, right? To get the answer. Because see, I've shown you that there are 2 double bonds here, so this bond will require 1 mole of hydrogen, this bond will require the second mole of hydrogen, and 2 moles of hydrogen means 2 times 24, 48 dm cube, done. This is how easy this question is. But as a student, you don't need to know this. So ab kya kare? What to do? There are 2 ways to go about it. One is the mathematical way, one is the trial and error way. Sir, what do you mean? I'll show you. See, the examiner is saying it's a 6-membered ring. So it's 2, 3, 4, 5, 6, right? This is the 6-membered ring. So you have 6 carbons, and here he's shown you the molecular formula, which is for 10 carbons. So you've drawn 6 carbons, then all the other, since you don't need to know the structure, it doesn't need to be correct. You don't need to know the structure, so it doesn't need to be correct. Just follow the lead. 6 members should be the ring, so the other 4 carbons must look like this. 1, 2, 3, 1, 2, 3, and the 4th carbon. So I have now filled out 10 carbons. These are 10 carbons right here effectively. I couldn't care less even if it's the incorrect structure. I don't care because it's going to give me the right answer. 10 carbons. Now let's start counting the hydrogens. I'm going to put a double bond here. Just by the way, just to show, yaar, ek double bond to ho sakta hai na, because see, in the exam, the options that you are given means कि यार एक ना एक double bond तो है. So one double bond I'll put on my own. Let's see कि क्या बनता है. One double bond I'll put on my own. So if 10 carbons, how many hydrogens do I have with one double bond? This is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you end up with 18 hydrogens if you put one double bond. But so now I know कि अच्छा एक double bond के साथ I end up with C10H18, but the formula is telling me that it's C10H16, which means there must be another double bond. Wherever you want to put it outside for all that matters, put it inside for all that matters. Couldn't care less, put it outside or inside, doesn't matter, because once you put the second double bond, you'll realize that here you have the same 10 carbons, but now the hydrogens have been reduced to 16 hydrogens, and so the structure would look something like this: 2 double bonds, and that means 2 times 24, 48 dm cube. C is the correct option. That's one way, which is called the trial and error way. There's the third way of doing it. The first way was you rote learn the structure, which I don't recommend. Don't rote learn it. The second way is to do trial and error. Even if the incorrect structure, you'll end up with the proper answer. The third way is the mathematical way. What's the mathematical way? See, if it were an alkane, the formula for it would be what? C10H. If it were all single bonds, no cyclic structure, no nothing, all single bonds, what would the formula be? If you had 10 carbons and they were all single bonds, what would the formula be? What would the formula be, guys? What would the formula be if it were just single bonds? It would be an alkene, right? And what is the formula for an alkene? Come on, don't let me down. Don't let me down. It would be C10H22. The number of hydrogens should fit the formula, right? CnH2n plus 2, right? So jitne carbons hai, hydrogens are twice the number of that plus 2. This would have been the formula for it, C10H22, if it were an alkane and they were all single bonds. But we know that cyclic fellas, if you have a cyclic component, we know that cyclic component fits the molecular formula of what? Although they are also alkenes, but they fit the molecular formula of what? Of what? Of an alkene, which means you're going to reduce 2 hydrogens from it because of the cyclic fella. Okay, 2 hydrogens gone because it's cyclic. Then, now you're left with 20 hydrogens, and the molecular formula that he's given you is 16. So you subtract 2 more and 2 more to end up with 16. So 2 subtraction is because of the cyclic component, and the other 2 must be because of the double bonds, right? So they are effectively what? One double bond and the other double bond. So they are effectively 2 double bonds. And so 2 double bonds means 2 times 24, that's 48 dm cube. That's the mathematical way for it. So it's up to you how you like it. If you're good in math, follow this. If you're good with logic, follow that. If you're good with rote learning, follow that. Oh wow, sir. That's good, Bidisi, that you liked it. There are so many ways of doing chemistry. It's just however you want to do it. Beep, beep. Tired. Next. MCQ 13. An addition polymer da. What is the polymer from this mono? Again, the concept that I have given you. Please follow my lead. The carbon and carbon which has made the double bond, put everything above and below it. And just break the double bond and make the connectivity bonds. That's all. So see, I'm going to put carbon. This is hydrogen and hydrogen, and I'll put the double bond as it is. This is carbon, hydrogen, and then this is carbon, hydrogen, and I'll put all of this below it. I couldn't care less because it must be above and below the carbon to double bond it together. So this is COOCH2CH3, and then you just finish off this double bond. So double bond breaks, and just show the connectivity bonds and check out your options. Tuck and tuck. So which fella fits this option? Not this, and not this, and this. C is the correct option, because if you look at C or D, sorry, it's D which is the correct option, not C, because what the hell is this in C? So C is not the correct option, it is D, because in addition polymer, see, this is CH2, CH, and then this COOCH2, CH3, COOCH2, CH3, boop, 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 boop. Say boop, boop. Easy, guys. Okay, next. Which alkene shows geometric isomerism? In geometric isomerism, we know that both carbons in the double bond must be bonded to what? Two different atoms or two different groups. This must be different and this must be different. If you look at A has one of the carbon in the double bond is bonded to two hydrogen atoms, which is the two same atoms. So can't show cis trans, which is geometric isomerism. And geometrically, the other idea is what? Cis trans. And optical isomerism is not geometric, right? They both fall under this umbrella of stereoisomerism. So optical is when you have a chiral carbon. He's just asking about geometric isomerism, not optical, please. So this guy fella, see, this carbon in the double bond has a hydrogen, and it has this alkyl group, this has a hydrogen, and this fella. So this will exhibit cis trans. Absolutely it will, right? And if you look at C has a CH3 here and a different group here, so that's good. But this fella, again, the same two atoms bonded to the carbon, so C is wrong. And like a D may, this is different, that's different with this carbon, but the right carbon has CH3 and another CH3. So again, no cis trans. D is wrong. So B for ball is the correct option. 15. MCQ 15. What is the correct name for the major product? Okay, major, which means that the more stable carbocation intermediate would form. Or using the Markovnikov's rule, the hydrogen should bond to the carbon with more hydrogens. Or using the more substituted carbon rule, the more substituted carbon should have the positive charge, which means the carbon which is bonded to more carbons should have the positive charge. It's up to you which idea you were to use. Actually, you have HBr3 ethyl hex 3ene. For you to first, make this idea come into reality and solve the option, please make the diagram for this. So how do you make this diagram? You first make hex 3ene and then you put the ethyl on the third carbon. So let's make hex 3ene 1. Hex means 6, so 1, 2, 3, 4, 5, 6. And hex 3ene means that the carbon-carbon double bond should be between the third and the fourth carbon, right? 1, 2, 3, 4, 5, and 6, right? So that's the idea. Now, he's saying that it's on the third carbon you have ethyl. So on the third carbon, I'll put the ethyl here. On the third carbon, I have C2H5. That's ethyl. Right, good stuff. Now, where would, or I'll put the C2H5 on top, C2H5 for better visualization. Where would the H go and where would the Br go? We know that the double bond is now supposed to break. The double bond would break when the electrophilic addition takes. I'm not going to show you the mechanism for it because it's useless. I have to quickly solve this MCQ. So where would the hydrogen go? Obviously, see, this fella had one hydrogen here and this fella had no hydrogens. So the hydrogen would bond here and this would be the more stable carbocation intermediate and Br would bond here. That's one idea. The second idea is to say, hey, the double bond breaks. This carbon is bonded to an ethyl group here and an alkyl group is bonded to two alkyl groups, whereas this fella is only bonded to one alkyl group. So this is the more stable carbocation intermediate. This will have the positive charge and the hydrogen would bond here, and then obviously the Br fella would go here, right? So this is how it would look then. 2, 2, 2, tuck C2H5. This is CCC. CCC, this was the hydrogen and this is the Br. That's the major product. Tuck, 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 tuck. So what's the name of this fella? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, the name is the same. You just say, hey, on the third carbon, you also have bromo. So instead of saying fourth carbon has bromo, the third carbon has bromo, and it's 3 bromo, 3 ethyl, hexane now. So B is wrong. A is the correct option. How can it be 4, right? It's 3. On the same third carbon, you have the Br and the ethyl. So it's 3 bromo, 3 ethyl, meth, eth, pro, but, pent, hexane. Easy peasy. सुनो ना एक बार मैं हूं ना. When heated with KOH dissolved in ethanol, haloalkenes can undergo an elimination reaction. It's KOH or NOH, remember? Why would it go elimination reaction when you dissolve in ethanol? Because the OH will now act as a base. In elimination reaction, the OH acts as a base, but if it were NaOH or KOH aqueous, then it would undergo the nucleophilic substitution reaction and the haloalkane would form alcohols. But here, when it undergoes the elimination reaction, the haloalkane forms alkenes, and he's even told you this. See, when elimination reaction forms alkene. What are the possible elimination products of 2-bromobutane? So it's meth, eth, proper, bute, and you have on the second carbon you have a Br. Now these are all hydrogens, and for elimination reaction to take place, the adjacent carbon must have a hydrogen directly bonded to it. And you realize that, hey, in this fella, this carbon which has the Br has an adjacent carbon with the hydrogen bonded to it, and this fella also has the adjacent carbon with the hydrogen bonded to it, right? So this fella can be eliminated in totality, and this fella can also be eliminated in totality. So you can end up with what? You can end up with a double bond between these two fellas and between these two fellas, right? So you can end up with what? 2 tuck tuck tuck, or you could end up with tuck tuck and double bond here and tuck tuck, right? So you can end up with bute 1-ene or bute 2-ene effectively, right? And then this can further show cis trans, nobody cares, right? So A and B are wrong. You can only end up with C or D. And then if you look at C or D, what the hell is this? What the hell is this? A double bond here and another double bond here. There must have been 2 Br atoms for this to happen, right? But they aren't 2 Br atoms. There's just 1 Br atom, 2 bromo. The examiner effectively tested the concept whether students know that this 2 bromo means the position or 2 bromo means 2 bromine atoms. So 2 bromo does not mean 2 bromine atoms. 2 bromo means the position of the Br atom. So D is wrong. And that's why C is the correct option. See, CH3, CH, CH, CH3. This is bute 2-ene and this fella is bute 1-ene. Because you start numbering from the right, and here you start numbering from the left because the double bond is closest to the left. Here you start from the right. In both cases you end up with bute 1-ene. Done. Next, which statement about PVC is correct? Now this shouldn't be tested. Why? Because you're not supposed to know what PVC is. Polyvinyl chloride. It's polyvinyl chloride or polychloroethene. Polychloroethene. Now see, as a student, I'm not supposed to know anything, but there are in A-level MCQ, you just have to be smart about it. That's what I'm here to teach you, how to be smart about things. Now as a student, it's a good thing that you know that PVC polyvinyl chloride hota hai, polychloroethene hota hai, it's used in pipes and blah 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 blah. But let's suppose I'm a student of chemistry. I've only studied the structured course of Cambridge, which does not require me to know PVC kya bakwas hai. ठीक है, although O levels में आपने पढ़ा हुआ है, लेकिन forget about it. Bakwas, I don't know jack shit now, right? So I'm gonna weigh my options here. Let's see. Combustion products of PVC are very alkaline and harmful to breathe in. Now as a student, I know that this is incorrect. I know as a teacher, I know it's incorrect. But as a student, sir, किसी दिन मैं out of syllabus. No, it's not out of syllabus. It's not out of syllabus. Cambridge tests your patience and your knowledge and your smart thinking. So as a student, I would not know this. Whether it's going to give you alkaline and harmful things, although it does not give you any alkaline stuff, it forms HCl, which is not alkaline, it's an acidic gas, but forget about it. Let's suppose I don't know that shit. Right? Let's suppose I don't know. So I'm going to say, hey, I don't know this. Molecules of PVC are unsaturated. I know for a fact this is incorrect. Why? PVC के molecule polyvinyl chloride is a polymer. Polymer does not become unsaturated. Then when polymer forms, the double bond breaks. When the double bond breaks, you'll have all single bonds. So polyvinyl chloride, PVC or polychloroethene is not going to have a double bond, would it? Because when it becomes a polymer, it's just single bonds. That's why it's very hard to degrade. It's a non-biodegradable fella. So C though is incorrect. The repeat unit of PVC is CH2CCl2. Now again, I know that it's chloroethene, but let's suppose I did not know this. I did not know this even. I did not know that, polychloroethene is not CH2CCl2. It's basically what? It's CH2C and it's a Cl and that's a H. That's the repeat unit, right? But let's suppose I did not know this. It's okay. I don't know this. Let's read B. The empirical formula of polyvinyl chloride is the same as the empirical formula of the monomer. And that should make sense to you, and you should circle B out of ABD. Do you know why? Because see, when a polymer forms, what is a polymer? A polymer is basically when many small monomers join together. So if I say, hey, you have 5 balls, right, which I call my monomer, and I say, hey, there are 5 5s which join together. So 5, 5, 5, 5, right? What would be the empirical formula for it? The empirical formula, if you simplify all of this, you'll end up back into 5. Because understand that the polymer is just made up of many monomers joining together. So whatever the formula for the monomer is, the empirical formula of the entire polymer would be the formula of that single unit. That makes sense, doesn't it? It does absolutely make sense to you. That's the idea. And we know what empirical formula is: the simplest whole number ratio of all the atoms or ions in a particular compound or a molecule, right? So you understand, okay, if I take the simplest whole number ratio, it'll end up with the molecular formula of that particular monomer, because a polymer is effectively what? It's just many simple monomers join, right? So I'll circle B. Done. वैसे मैंने अपनी लाइव क्लासेस में पीवीसी पढ़ाया हुआ है. अगर आप लोग जिनको बड़ा शौक हो रहा है, याद है वो एंड में आई पुट अ डायग्राम, उस डायग्राम में लिखा था, आई टोल्ड यू टू जस्ट गो ओवर दिस डायग्राम. वो एक बिग फैट बॉक्स की पिक्चर थी जिसमें पीवीसी, टेफलॉन, ये सारी चीज़ें लिखी हुई थी. एंड आई सेड जस्ट गिव इट अ लुक. You don't need to know it, just give it a look. So see, this is how sometimes you need to be careful. 18 MCQ. Butene reacts with cold dilute KMNO4. Okay, butene. So butene looks like this, tuck. This is the cis version of it, tuck. This is the trans version for it, right? Couldn't care less. Or if you want to just draw butene, this is how it looks. I've drawn the trans version. This is the trans version, right? Now, butene, when it reacts with cold acidified potassium manganate, what happens? In cold acidified, diols form, tuck. A diol forms, double bond breaks, diol, tuck and tuck, diol forms, diol. And when it's hot, what happens? When it's hot, see, it's CH3 bonded to CH, double bonded to CH, CH3. When it's hot, this double bond is going to tuck, break. You have a C bonded to H and a CH3, and obviously this gets the O and becomes aldehyde. But जैसे ये aldehyde बनता है, the O comes here and the H comes here. The H is just pushed aside and it forms a carboxylic acid, and both will form carboxylic acid. Only one carboxylic acid forms, right? So here you end up with diol, and here you just end up with a single carboxylic acid. And what is the name of this carboxylic acid? Metheth. This is ethanoic acid, by the way. Nobody cares. Now it's saying, okay, which statement about products S and Y correct? Both products at X and Y will react with 2,4-DNPH? No, because 2,4-DNPH will give you a test only if you have a carbonyl fella, but not the carbonyl of carboxylic acid. Remember this. 2,4-DNPH and even the iodoform reactions, they only gives you test. Iodoform to methyl ketones के साथ, ethanol के साथ करता है, and obviously ethanol, and then secondary alcohols. And 2,4-DNPH only gives you a test with ketones and aldehydes. It's a carbonyl test. I know it's a carbonyl carbons test, but remember I told you in the live class that carboxylic acids there's an idea which we'll study later on in A2 chemistry, which has to do with delocalization of pi electrons. इसलिए ये 2,4-DNPH के साथ कोई टेस्ट आपको नहीं देगा. Even if carboxylic acid looks like this, it's not gonna, neither is it ever gonna give you a test with 2,4-DNPH, nor will it ever give you a test with what? Nor will it give you a test with NaOH plus iodine and warm, which is iodoform. Because remember, in iodoform you study this idea कि यार iodoform में it tests for the CH3CO group of atoms, and you have CH3CO group of atoms, but that's only if you have a methyl ketone, a secondary alcohol, or a primary alcohol which is only ethanol, or an aldehyde which is only ethanol. That's all. It will never give you a test, never, with carboxylic acid. And the reason, A2 chemistry. So both products X and Y will react. No, Y won't. X and both X and Y would react with 2,4-DNPH. No, neither X nor Y, because 2,4-DNPH के साथ ketones and aldehydes give you the test, which gives you a yellow precipitate or an orange precipitate. It's up to you whether you add yellow or orange. Both are correct. So this fella is a diol, not an aldehyde or a ketone. So neither would give you a test with 2,4-DNPH. Neither product X nor product Y gives me a test with 2,4-DNPH. Yes. Product X will react with 2,4-DHPH? No. Product Y would react with 2,4-DNPH? No. It's the aldehyde and ketone which will give you a test with 2,4-DNPH. Last MCQ for the 2024 set, and then we're done. What is the correct name for the monomer? Again, let's just draw the entire file and then we'll figure out the monomer. So this C is bonded to a H and CH3. This C is bonded to a H and this fella. So let's draw it. See, C bonded to a H and CH3. And then you have a C bonded to a H and this fella, CH2, CH3. And then you just put the double bond right here. See, this and this just becomes the double bond. Now what's the name? Select the longest carbon chain. 1, 2, 3, 4, 5. And it's 1, 2, 3, 4, 5. It should be pentene and pent2ene. See, pent2ene. Between the second and the third carbon, you have the double bond. So it's pent2ene and that's C for salt. See, students who don't know how to select the longest carbon chain would probably select A or B, which is incorrect. And it's not pent1ene. You see the double bond is between the second and the third carbon. There you go. You're done officially with the 20 MCQs for the 2024 set. Easy, guys. I think I've gotten full marks. I don't think I know for a fact that I've gotten full marks. I know. Guys, I tell you, chemistry is the easiest subject to ace as long as your concepts are clear and you're studying from a good teacher. That's all. Yes, I am 12-year-old. Thank you very much. Kill yourself. Huh? Kill yourself. I'm joking. Any questions, guys? If I were not doing my corporate job right now, I swear to God, I would stay with you all every single night, every single day. I'd just be doing chemistry. But unfortunately, I'm a corporate slave. I need to work in corporate because that gives me, that's supposed to mint me a lot of money. Yeah, but it doesn't. I mint a lot of money from other businesses. The corporate skills are there, which help me set up a lot of businesses. But sir, please do that again. Screenshot lene. Here you go. Yeah, I'd look disgusting. My mom would kill me. Will there be a class tomorrow? I don't know. Solid money. Are you actually solid money? Give me solid money and I'll conduct a class every single day. Sir, please add goofy. क्यों नहीं मैं मस्खरा लगा हुआ हूँ इधर. Please add goofy. नहीं है ये मेरा दीवानापन. Can you send it in the group or will I get kicked? Fatma, you know I'm a chill guy. I won't kick you. I'm not like the other teachers. Teachers के इज्जत के वैसे के इज्जत के अगर इज्जत I'm not that type of guy. Just don't abuse me. Whatever you do, then just do it. गालियाँ ना दें. Sir, I can't imagine a sane person teaching high school's chemistry for fun. It's fun, is it not? You are crazy, sir. No, I'm not. It's fun. Is it not? Like, आप लोगों को मजा नहीं आता मेरे साथ बैठ के. I love interacting with students. I love it. Seriously, I'm not even joking. I'd rather watch some show or something. No, यार. हाँ, अगर मेरी शादी हो जाए नियर फ्यूचर में 2-3 साल में अगर मेरी शादी हो गई तो फिर मैं अपनी बेगम के साथ हूँगा. बेगम. फिर आप लोग भी बेगम हो जाए मेरे से. फिर आप लोग रोएंगे. खैर फिर आप लोग पास आउट हुए होंगे. You guys would have been done with chemistry, so you guys wouldn't care less. But please move your screen a little to the left. Okay, here I moved it a little to the left. Bus. But yeah, then probably you'll be done with. Even you'll be midway through your unis probably when I get married in the near future. 2-3 साल में, you know, maybe, I don't know. Parents are telling me यार शादी कर लो. मैं कहा करा दें जो मर्जी. खैर, but yeah. So the thing is कि then the juniors will say यार क्या खुशनसीब लोग थे जिनके साथ सर सारा दिन रात बने. फिर जब बेगम आ जाती है फिर तो बेगम ही होती है. फिर मैं उनके साथ मूवियाँ देखूंगा हैं. है आप लोग गए बाढ़ में. Sir, will the GC be dismissed after we are done? No, no, it will never be dismissed, Benazir. I have never, till date, I have never dismissed a single GC in my life. Because I want you all to stay in touch with me. Sir, वो 10 CO2 और 8 H2O का, sir, show the answer of the MCQ. Why? Sir, वो 10 CO2 और 8 H2O वाला क्वेश्चन किस वेरिएंट का था पता नहीं. देख लेते हैं. वो वेरिएंट था, लेकिन बकवास सा सवाल था, इसे फजूल. कैमरे जो है ना पागल हो गया था, दिमाग ख़राब है इनका. बेखैरत, बेशरम, बेहया, फजूल साइकोलॉजिकल गेमें खेलें. 1 वेरिएंट का था, आपका नहीं था. आप चिल करो. बच्चों को बस अपनी फिक्र होती है. 1-2 का तो नहीं था ना, 1-2 का तो नहीं था. हमारे सर ने कहा है सिर्फ 1-2 के MCQs करें, 1-1 और 1-3 के MCQs. बेटा अपने सर को कहो ना मर जाएगा. आपस की बात है, क्योंकि सुकून सिर्फ कब्र में. इधर उनको सुकून मिलना नहीं, क्योंकि इधर मैं हूँ और मैं सांप हूँ. मैं फिर किसी की जान नहीं छोड़ता. जो मुझे पता है कि जो है बच्चों की ज़िंदगी अजाब कर रहे हैं. आई एम प्रो स्टूडेंट्स. The moment you guys are fed up with me, I will stop teaching. I swear to God, I will stop teaching. If you guys get fed up with me, स्टूडेंट वगैरह सर आप पढ़ा नहीं सकते ना, छोड़ दे पढ़ाना, अल्लाह की कसम मैं छोड़ दूंगा. मुझे क्या, मैं छोड़ दूंगा. मुझे क्या परवाह है. I am pro student. I am on student union side. बेटा मैं कैम्ब्रिज की लीक्स जब हुए थे ना, अल्लाह की कसम I was the only teacher, because I was not teaching A levels back then. I was teaching just O levels. A levels तो मैं आप लोगों की वजह से शुरू किया, इतना ज़्यादा डिमांड था. But one thing, I wasn't teaching A levels, but mind you, I'm not saying this to यार कि मैं कहूँ मैं बड़ा अच्छा इंसान हूँ, but I was the only teacher who raised his voice and said boycott Cambridge, move and opt towards PSN and Excel, move and opt towards IB curriculum, move and opt towards FSC metric curriculum. I was the only person. Yes, there were some teachers who raised their voice and hats off to them, but they never talked about boycotting Cambridge. Do you know why? Because their bread and butter depends on it. And I just do this as a hobby. I'm not, holding anybody accountable for this, but this was the right move for all the big teachers to come together and literally boycott Cambridge examination for two consecutive leaks. And not just in a single paper, in multiple A-level papers. I was the only teacher in the entire market. You can search it up. You can search on my YouTube videos. They are still up, in which I'm saying to all the teachers to come join hands, to institutes to join hands and boycott Cambridge so that they never do this thing again. They are literally placing the lives of the futures of students at stake. Literally. सर अगर आप डॉक्टर होते तो सबको कहते हाँ मिड सर्जरी, सर सुलेमान मिड सर्जरी. ओहो यार ये तो बहुत बोल रहा है, मर जाओ. That's funny. That's actually funny. So this is the thing. I've always been pro student. मैं दिल से ना स्टूडेंट ही हूँ. दिल से I'll always be a student. No matter if I'm 40, 45, 50, जो मर्जी उम्र आ जाए ना, मैं हमेशा एक स्टूडेंट रहूँगा. मैं हमेशा स्टूडेंट्स के राइट्स के लिए जो है बात करूँगा. और इसकी वजह यह है सर तना फॉर केमिस्ट्री वी गेव योर नेम फॉर ईयर. दैट्स ऑसम फातिमा, लव यू ऑल. बट दैट्स द थिंग गाइस, मेरा ना बस ये कि मैं चाहता हूँ, मेरे ना किसी टीचर के साथ कोई मुकाबला है ना कुछ है. मैं चाहता हूँ कि स्टूडेंट्स को उनका हक मिले. स्टूडेंट्स का हक क्या है? उनको अच्छे तरीके से पढ़ाए, इंसान के बच्चों की तरह उनको पढ़ाया जाए. सिर्फ उनसे पैसे ना लिए जाए, पैसों के एवज उनको पढ़ाया जाए इंसान के बच्चों की तरह. ठीक है, अपनी टीचर्स को अपनी रिस्पॉन्सिबिलिटी, अपनी लाइबिलिटी डिस्चार्ज. क्या जवाब देंगे? ये तो लंबी लंबी दाढ़ियाँ दे के मूँचे काट के जो है ना बड़े आ जाते हैं. क्या जवाब देंगे आखिरत में? कैसे मैंने बच्चों को पढ़ाया, कैसे देंगे? Zara is saying how to get grip of concepts. Zara, I am responsible for my own show, and my own show is my own lectures. I am responsible for that, kiddo. मैं तो कहता हूँ मेरे लेक्चर्स देख लो, आपके सारे कॉन्सेप्ट्स क्लियर हो जाएंगे. मैं तो यही कहूँगा आपको. बाकी अगर टाइम नहीं है वो सारा देखना है, सब कुछ देखना है, 134 लेक्चर्स हैं, बाकी आप देख लें. लेकिन ये है कि मैं तो बस यही कह सकता हूँ. और बाकी उसके अलावा नोट शूट्स किसी मेरे स्टूडेंट से, किसी अगर नहीं कर लेना चाहते लेक्चर्स तो मेरे किसी स्टूडेंट से नोट्स ले लें जिसने अच्छे बनाए हैं, उससे नोट्स लें, नोट्स पढ़ लें और प्रैक्टिस कर लें. टॉपिक वाइज ईयरली मत करें. सर काश आप मैथ भी पढ़ाते ना. बेनज़ीर, आई टेल यू समथिंग. मैथ का आई टेल यू समथिंग. इफ़ यू वांट टू बी गुड एट मैथ, watch your teachers, whoever, math lead by Saad, Zanamatics, Flana Timkana, जो जिससे भी आप पढ़ें, अच्छे टीचर्स हैं, सारे अच्छे टीचर्स हैं. They'll get the job done, right? They'll get the job done. But if you want to learn math, लर्न फ्रॉम द बुक। हाँ, मैं सर साया भी मैंने सुना है बड़े अच्छे टीचर हैं, देर ऑल गुड टीचर्स ए लेवल्स में, बट इफ यू वांट टू लर्न ए लेवल मैथ कॉन्सेप्चुअली, लर्न इट फ्रॉम द बुक। बुक आपको कॉन्सेप्ट सिखाएगा, शॉर्टकट्स और टोटके आपको ये अपने टीचर सिखाएंगे। बुक आपको कॉन्सेप्ट सिखाएगा, जो कि मेरा ख्याल नहीं है जो आपको जो थॉट प्रोसेस आपको बुक देता है ना उतने, क्योंकि इन टीचर्स की मजबूरी है ना, इतने शॉर्ट पीरियड ऑफ टाइम में वो आपको पूरी कहानियां तो नहीं पढ़ा सकते ना किताबों की, और ना दिल का जोर होता है और पूरी किताबें पढ़ा भी नहीं सकते। वो आपको सवाल कराना सिखा देंगे। तो इनसे टीचर से सवाल करना सीखें, कॉन्सेप्ट जो है ना वो बुक से पढ़े, असल कॉन्सेप्ट। टोटके सीख लें, लेकिन टोटके जो है हर जगह अप्लाई नहीं होते। जब मैथ का A2 का पेपर 3 जब टकराता है ना आपको, ओए होए 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 होए, सब कुछ, एक सवाल भी इधर उधर से आ गया तो गए। तो ये है कि ये हिसाब किताब है सर। फॉर ईयर आइडिया फॉर द फर्स्ट, हाँ फिजिक्स, देखो फिजिक्स के, दिस इज माई रिजर्वेशन बाय द वे। These are, sir, where would you get your lectures? It's Miss Naiba को contact करें। Miss Naiba का number, somebody throw it in the chat box. What is Miss Naiba's number? Somebody throw it in the chat box. यार मैं इसे भूल जाता है यार। Miss Naiba, okay? नाइबा, यार मुझे मिस नाइबा का नंबर याद नहीं होता ना। इट्स व्हाट 0318, मैं इधर लिख लेता हूँ, कोई थ्रो इन कर ले, बट इट्स +92 318 177 2015। मिस नाइबा, ठीक है, वो हैंडल करती हैं सब कुछ। खैर, एक दो बातें याद रखें, फिजिक्स के लिए भी, केमिस्ट्री के लिए भी, मैथ के लिए। अब केमिस्ट्री जिन्होंने मेरे से पढ़ी वो उन्होंने पढ़ी है। केमिस्ट्री ऐसा सब्जेक्ट है ना जो शायद किताबों से ज़्यादा आपको ऐसा टीचर अच्छा पढ़ा सके जो जिसने सब किताबें पढ़ी हों, क्योंकि केमिस्ट्री आप कभी एक किताब से सीख नहीं सकते। उसकी वजह ये कि कोई किताब जो है ना वो इतनी अच्छी नहीं। हाँ, अब जैसे जॉर्ज फेसर की किताब है पीएसएन एंड एक्सेल की, उसमें बातें सिंप्लीफाइड फॉर्मेट में लिखी हैं। आईबी की किताब में एडवांस्ड चीज़ें लिखी जो बहुत मज़े की हैं, जो उसके साथ कोरिलेट होती है। केम्ब्रिज की किताब में कुछ एक्स्ट्रा डिटेल लिखी। तो अब ये टीचर का काम है कि उस सब को कंबाइन करे और आपको एक मजमुआ पेश करे आपके सिलेबस के मुताबिक। ये केमिस्ट्री की बात होगी। फिजिक्स की जिधर तक बात है वो मैं आपको, फिजिक्स और मैथ का मेरा हमेशा से ये मसला रहा है कि these teachers in the market are really good. सर काशान हो गया, सर तला हो गया, सर नौशेर आलम हो गया, अली हो गया, ये सारे अच्छे टीचर्स हैं, कोई शक नहीं। लेकिन मैंने इन सब टीचर से ये गिला है, मे बी आई एम रॉन्ग, आई डोंट नो, एवरीबडी इज एंटाइटल्ड टू देयर ओन ओपिनियन, लेकिन मैंने सब टीचर से ये गिला है कि यार व्हाई आरंट वी इंट्रोड्यूसिंग मोर प्रैक्टिकल स्टफ इन फिजिक्स, बिकॉज आई ऑल्सो हेट फिजिक्स टू बी वेरी ऑनेस्ट। आई वुड हैव लव्ड टू टीच फिजिक्स बट आई हेट इट, हेंस आई डोंट टीच इट। बट ये है कि मेरे इन सबसे ये गिला है कि यार आप उसको चीज़ों को डेमोन्स्ट्रेट करके देखें। फिजिक्स में हर एक कॉन्सेप्ट आप बच्चों को दिखा सकते हैं, हर एक कॉन्सेप्ट। एज ग्रेविटी से उठ के ना आप जो है, वॉल्टर लुइस एक बंदा है, यूट्यूब पे सर्च करें, किनेमेटिक्स में वो जो आपको जो प्रैक्टिकल करा के दिखा रहा होता है ना, आए हाय हाय क्या मजा। अगर टीचर करा नहीं सकता ऑनलाइन क्लास में कोई इशू नहीं है, आप जो है जो टीचर है वो वीडियोस दिखा दे, हर कॉन्सेप्ट पे एक वीडियो दिखाए, हर कॉन्सेप्ट पे एक वीडियो दिखाए। अब केमिस्ट्री ऐसी चीज है इसमें मैं आपको कहूंगा इमेजिन करें, इमेजिनेशन कराऊंगा, डायग्रामें दिखाऊंगा, पिक्चर्स दिखाऊंगा, आई एम डूइंग दैट टू द बेस्ट ऑफ माई एबिलिटी। बट ऑब्वियसली फिजिक्स इज मच मोर प्रैक्टिकल। फिजिक्स तो आपके आंखों के सामने है सब कुछ ना। केमिस्ट्री के लिए तो मैं आपको कहूँ इमेजिन दिस, अर्विन श्रोडिंगर मॉडल आया, वो आया, ये हुआ, तो मैं कुछ इमेजिनेशन पे भी आपकी रिलाई कर रहा होता हूँ। लेकिन फिजिक्स तो यार कम ऑन टीचर्स, if you're watching these videos, I love you all. Walter Lewis है कि Lewis Walter है, something, he's now retired from MIT. That guy used to make physics, मतलब मैं उसके ना I still watch his videos just for fun when I'm just eating food. मैं कभी उसकी वीडियो लगा देता हूँ। वो किनेमेटिक्स इतना अच्छा पढ़ाता था, वो इधर से ऑब्जेक्ट, वो हर चीज ना, गाड़ियाँ। वॉल्टर लुइस है कि वाटर तो नहीं, वॉल्टर लुइस है कुछ ऐसे। सर सरदार इज अ गुड टीचर। अली, तो मैंने अली का है ना, यू नो हिम एज सर सरदार, मैं उनको अली से जानता हूँ, मैंने अली का है। सर माई कॉलेज मैथ टीचर इज सो बैड, लाइक इवन द टॉपिक्स आई हैव कंप्लीटेड एंड देन आई सिट इन हिज क्लास फॉर दोज टॉपिक एंड स्टिल अंडरस्टैंड नथिंग। यही है यार, मैं आपको बता रहा था, मैं तो आपको शुरू से बताया बेटा, मेरी क्लासेस अगर आपने नहीं, मैंने पूरा गाइडेंस सेशन किया है, बल्कि मैं रिकॉर्डिंग बंद करके गाइडेंस सेशन लूँ, अभी लूँ 10 मिनट में मैं सब कुछ दूध का दूध पानी का पानी कर देता हूँ। स्टॉप रिकॉर्डिंग कि व्हाट इज